And then what is forward and backward propagation? You might already heard this word in deep learning many times. The forward propagation is actually get from the input all the way to the loss. So in logistic regression, we have this NX input and we do a combination, and then we direct connect to that combination after activation function, direct connect to the output. So technically, depending on how you define hidden layer, it's not a hidden layer. The layer, it's the output layer that connected to output. So logistic regression doesn't really have hidden layer. So it's a zero hidden layer neural network. And then the forward propagation is the process from input, and you calculate the accumulated signal, you apply activation function, and you calculate the loss. That's forward. And backward is the way go from the loss back the information forward to update each parameter. So you can see the backward is you do derivative with respect to the activation function, and then with respect to the linear combination of the signal, that's Z, and then you further do derivative with respect to different parameter W1 and B1. And you update the parameter. So that's backward. So the whole optimization process is sweep over forward, backward, and continue until you get the accuracy. So then what is stochastic gradient descent? If you write everything out, this is what you would do for this logistic regression problem. And then here we use one sample each time. You might ask, what's the difference between stochastic gradient descent and maximum likelihood estimate? It's very similar, just the way you update it. Maximum likelihood, you vectorize it, and you use all M samples to update it. And then stochastic gradient descent, you just use one sample each time. With this specific cost function, it's the same. You should get very similar results. You initialize W1 to W and X and B, W and B, and then you do forward. You put those weight, you do a linear combination, calculate all the way, you calculate the prediction and the cost. And then that you finish forward, and the next step you're going to calculate the backward. And the backward, you will calculate all the derivative. In application, you don't do the analytical form of derivative. You use numerical approximation. Here, since it's a very simple example, so we can write it out, the analytical form. So you do derivative with respect to each of the parameter, W1 and B, W1 to W and X and B, and then you update the parameter using a learning rate, multiply the derivative, and use W1 minus that product, and so on and so forth. First, you can update all the parameter, and after you update the parameter, you go back and it goes through the forward and backward again. We repeat the process. So it is called stochastic gradient descent when you use one sample each time and you do forward and backward update the parameter. It's called stochastic gradient descent. We will talk about other batch and mini batch gradient descent where you use more than one sample to update the parameter.